Let's resume our introduction on 5G, where in the previous class I was kind of telling you what was the vision of ITU R for the 5G, where I was mentioning about there are three broad use cases of the 5G in terms of EMBB, URLLC, and also what is that? Massive MTC. Basically, one is supporting users who want to have lot of bandwidth the way we are getting currently in the 4G. It is going to be 20 times more as you go to the 5G. And other cases supporting billions of IoT devices where the requirements are in terms of battery time and also in terms of the low data rate. It is exactly opposite to the way we consume data. And then we have a special category. It is geared towards uh, time critical and highly reliable system like robotics, drones, autonomous vehicles, industry 4.0 and all, where both the reliability and latency are extremely important. Of course, depending on the application, yeah, even other parameters are also equally important. These three are broad use cases. And one second, sorry. Okay, sorry. So this is the problem of having landline next to me. Okay, so where I was saying, I was talking about three cases. Third one being ultra reliable and low latency communication. The use case has some peculiar requirements and also very stringent requirements. And some applications may not exactly fall into one of these three broad use cases. But again, these are the three kind of categories that ITU has defined for the 5G. And now we'll look at how different technologies can kind of meet these requirements. So I was talking about in that context, what is 3GPP, where I was mentioning it is a kind of an umbrella organization which is formed by different standard development organizations, where recently India also has joined as one of the key partner in 3GPP, where all these organizations across the globe try to meet together and come up with some common standards rather than each country and each region coming up with their own specifications and standards. That way, 3GPP is more like a kind of an organization which is kind of bringing all of them together and agreeing on what should be part of a particular cellular technologies. Here in this context, we are talking about what 3GPP is doing in the context of 5G. Earlier, it has done for 3G, where it has kind of come up with something called UMTS, that is called also wideband CDMA for 3G. And later it has done similar thing for 4G, that we call it as LTE. In terms of ITU thing, we call it as IMT advanced. So in the case of 5G, we are talking about IMT 2020 requirement from ITUR, which 3GPP is trying to come up with technologies for meeting. So this also we discussed in the previous class. And 3GPP, as I was mentioning, it is a very highly transparent body in terms of making everything that it does in open source domain. That means all the meetings and all the presentations, all the specifications that 3GPP makes, they're all available for anybody to download. Like if you go to 3gpp.org, that link I am showing you at the bottom of this slide, you can able to get to see what 3GPP is doing. But unlike IEEE, and for example, if you look at a Wi-Fi standard, which IEEE does, of course, IEEE also has the members from different industries and different organizations. But the structure of 3GPP is so complex. As you see here, there are three broad groups or working groups in 3GPP who kind of try to bring specifications for different cellular technologies. So as you see here, there are three different columns. First one is called radio access network. Here we talk about defining specifications or the kind of standards between UVs and the network side. That means when you say UV, here stands for user equipment. That means mobile phones or any kind of device that is fitted with a radio interface is called as a user equipment here. So the RAN, the radio access network, basically talks about the kind of protocols that we have to provide for having communication between UEs and the core network. As you see, even in the RAN side, there are many different working groups as part of 3GPP. We have RAN 1, 2, 3, 4, 5, 6, which take care of different aspect of the RAN. And one of the most popular thing being RAN 1, which talks about the physical layer of the RAN. And RAN 2 and 3 talks about data link layer and IP layer. So like that, there are many different working groups who kind of work in parallel and try to come up with specifications and requirements for various entities as part of a given standard that they're trying to make. And if you look at on the right hand side, you see the core network. So core, I will talk about in the next class what is the architecture of 5G, then you will understand more. But in a nutshell, you can assume that we have the handsets which are connected to base stations, where these base stations are connected typically using optical fiber links to a backend network. It's more like a kind of a telephony exchange that telecom operator will have to kind of take care of billing, routing, and whatnot. So that is called core network. Very often, this core network is more like kind of your backend office. There's nothing like wireless out there. It is mostly for billing and network management and whatnot. That you can see it here. They are defining how the SIM card should behave as you go to the 4G and 5G, how different protocols should work, and how you have to take care of the mobility, the call control, session management, how the 5G should work with other technologies like let's say 4G and Wi-Fi. So all of them will be discussed by this CT working group 3. And in the middle, we have something at a very broad level, which basically looks at the overall network architecture of the 5G, which is comprising of both the RAN and also the core network. So it basically defines what should be the 5G network should provide and what should be the architecture. That means when I say architecture, what all the different network components, how they should interact with each other to meet the 5G requirements and the security codecs. And there are many different aspects these different working groups try to come up with in parallel. But at the end of the day, whoever is trying to make products, they have to make products by taking all the specifications which are kind of meeting the 5G standard and build products and including the base stations, core network equipment, and also the handset, where all of them should be able to interoperate with each other. By having a common standard across the globe, you can ensure that the devices will be produced en masse so that the cost will come down, and we have the devices which are sold in one country can work with operators of other country by just having the subscription or the roaming agreements rather than you requiring by a new phone or taking entirely a different kind of a cellular technology. So that is the beauty behind having these global standards and having 3GPP kind of an umbrella organization to bring everybody together to harmonize their requirements and come up with some common global platform for different cellular generations. Before I talk about the 5G timeline, let's quickly recap what has been done by 3GPP as part of the 4G. So if you look at here on the x-axis, you see the timeline all the way from 2008 to 2017. 3GPP has worked on 4G, the first version being release 8, where the standard of the 4G has been defined, including usage of the OFDMA as the waveform, where 4G operates not only in FTD, it also operates in TTD. So if you recall, in the context of GSM, I was mentioning that a handset is assigned both downlink and uplink frequencies. That's what frequency division duplexing about. Whereas TTD, where the example that I was telling you about is on cordless phones, where We don't use two different frequencies, use only one carrier frequency, but you do the uplink and downlink on different time slots on a TDMA frame. And another remarkable thing that 3GP has done is embracing IP uh, in the core network. So, in that sense, 4G is the first cellular technology that is all IP. So, everything that you do, including voice, is running on IP protocol stack are using IP as the layer 3 protocol. So whereas in the previous generation that was not the case. You don't require IP address, there is no IP switching, all that was not happening earlier. But from 4G onwards, of course, 5G also we continue the same legacy. But that way 4G is a kind of a remarkable in the sense it is all IP based packet switching network, very similar to the way you do the things in internet when it comes to establishing voice calls or establishing data sessions. Then you can see interestingly, I don't want to go too deep into this because a couple of years ago I used to teach only about 4G. Like some other releases that you see, I used to only teach about what 3GPP has done as part of these releases for 4G networks. But now we are kind of jump starting from nowhere to the 5G that is in the release 15, where the 5G work has been initiated. But if you look at here, each release of the 3GPP for a given standard, like in this case 4G, a new set of features and enhancements that are brought in. Like you can see, nowadays I think you can able to get voice over LTE on your 4G phones. So that if you have a 4G phone that supports only release 8, you don't get this feature. So if you really want to have a voice over LTE, even if the operator is providing and your phone doesn't support, then yeah, you cannot do that. So that way, each release comes up with new features, and depending on what operators feel as their revenue benefit, they try to upgrade their infrastructure or start introducing a base station that supports new features. Carrier aggregation is nothing but having multiple bands which are non-contiguous together to offer wireless services. That way I can take two 10 megahertz spectrum channels at a two different frequency bands, and I can able to combine them into one large 20 megahertz channel and able to provide radio resource to the users. And I was also talking about earlier about HETNet, the heterogeneous networks, a collection of macro cells and small cells. So those are actually brought into as part of the release 10, where how we can make sure that these macro cells and small cells work together without having any interference. When I say macro and small cell, I'm talking about deploying small cells like this, where at the center you can assume you have one large cell. If everybody is using same frequencies, you can expect the users will be getting lots of interference and SNR could be quite low. So you want to have higher capacity by doing SDMA, that is space division multiplexing, by deploying both macro and small cells. But at the same time, you want to make sure that your interference is low. So for that, in release 10, they brought in certain features. But you can see the evolution has not stopped with the release 8 or release 10. Thereafter, there is release 11, release 12, release 13, and release 14. That way, 4G network itself have seen 7 generations or 7 releases. But if you look at operators like Jio or Airtel India, more or less they might have only deployed product and solutions. They conform to one or two of the standards or the releases at max. But nobody stops them because these are all available. And we have manufacturers like Nokia, Qualcomm. They make products that conform to this. And especially if you buy things like iPhone and Samsung Galaxy and other kind of advanced phones, they support many of these things. But again, you having a phone with high-end features doesn't mean that you can really enjoy that, because you also need base station supporting the same thing. Same thing I was telling you in the case of Wi-Fi. Even if you have Wi-Fi 6 in our campus, and if you are still using old phones and old laptops, you don't get benefit out of latest generation of the Wi-Fi network that is deployed in our campus. You can see some interesting thing like vehicular communication, vehicle to vehicle, vehicle to network vehicle to the infrastructure. All that has been introduced as part of the release 14 to support some of the use cases related to collision avoidance and other things. And finally, the important one in the context of 5G is as part of the release 15, finally 3GPP has kind of kickstarted the work towards 5G standardization. So that way you can see in the following slide. Okay, so here, okay, before I talk about that, it is another timeline of 4G where you can see there are three different acronyms are kind of a main terms. The 4G has been kind of brand named or kind of branded as three different evolutions. One is called LTE, second one is called LTE Advanced, basically the release 10 onwards. And then finally we have this release 13 onward is called LTE Advanced Pro. So that way, even in 4G, we can assume we have three different variants. 4G, you can assume 4G plus and 4G plus plus. So why I'm using this term is you might have seen 3G, HSPA in your mobile phones, HSPA plus. So it is a kind of a similar evolution. It is in the context of 3G, but even in the case of 4G, what I'm showing is some kind of evolution. Even for 5G also, you see similar evolution where uh, some operators in some countries have deployed only the phase one of the 5G now. But 5G we are also going to see multiple evolutions as you see in the slide for 4G as the time progresses in the next 3-4 years. That way, the point I wanted to make is the word 4G or 3G or 5G, they don't really talk about one specific release or one specific variant that you see here. It is a continuous evolution. Operators can mix and match these things depending on what kind of services they want to provide. So let's again come back to our 5G's timeline that I was briefly showing you in the previous class. So this is where I was mentioning the work has been kickstarted in release 15 to identify what are the requirements, what should be the network components, how they should talk with each other to meet the IMT 2020 requirements for 5G. So here you see this acronym NR stands for New Radio. So the acronym that was used in the case of 4G was LT, that stands for long-term evolution. So similarly for 5G, they thought about having another acronym that is New Radio. When you say New Radio or simply NR, you can assume that we are talking about here 5G. Okay. So in release 15, it has been started. Then the idea is to have multiple releases similar to what we have seen for 4G. Right now, you can see from the illustration here, and the work for release 16 also completed. That means one can make products and deploy in the market, which conform to release 15 and release 16. The work is kind of delayed for release 17, which was supposed to complete by 2021, is getting delayed to the first quarter of 2022. Similarly, you can see that there will be delay for release 18 and release 19. This release 18 onwards is going to be called as NR Advanced. Okay. So earlier, if you recall, I was talking about here LTE, LTE Advanced, and here I'm talking about LTE Advanced Pro. You can see this similar kind of term going to be brought in the case of 5G, where the first three releases are called NR, then upcoming releases from release 18 onwards will be called NR Advanced, or they also maybe bring in again NR Advanced Pro or whatever it is. But as of now, these are the two terms that have been introduced as part of the 5G evolution. Okay, so this also we have seen in the previous class where I was talking about 5G standard is coming up in multiple phases. Release 1, release or phase 1 is the release 15, which covers enhanced mobile broadband use cases. And release 16 is supposed to cover all the requirements that are specific for enhanced, what is that, massive MTC and URLLC. But because of pandemic and because of lot of lobbying and lot of other issues during the standardization, things didn't go that fast. Because of that, some other things that they originally thought about putting as part of the release 16, were never finally part of release 16. They have been kind of pushed to release 17. That way, uh, some of the things that relate to the URLLC will be seen even as part of the release 17 release. Let's look at what is there in these different pages. You will be seeing different terms here. One is called non-standalone NR, other one is the standalone NR. Non-standalone and standalone. What basically non-standalone means is that is the 5G base station will play, like assume that this is my 4G base station and it is serving the users. So then you can assume that you have a 5G, this is 4G base station and this is 5G base station. So when I'm talking about non-standalone NR, basically it means that the 5G will be more like a kind of a supplementary link or network which kind of relies on the 4G network for all the backend activities and other things. So you'll understand this more when I actually talk about the 5G architecture in the following class. But you can assume that the meaning of non-standalone is 5G cannot survive or cannot provide any services if there is no anchor in terms of 4G base station and 4G core network. So that is the meaning of anchor. Basically, it's like a kind of the think more like a 4G is a kind of offloading some of the activity to the 5G, where whichever the 4G network has asked, 5G network will kind of take care, but it cannot survive or provide operations without backend support from the 4G network. That is called a non-standalone. So that is what the one of the phases of the 5G is talking about here. But then you can see later it is also thought about having standalone. That means even when you don't have the 4G base station, an operator can directly deploy a 5G base station which is connected to their backend network and provides the 5G operations. The reason why it has been done here is the main reason being already many operators have deployed their 4G networks, and the idea being this is since there are many base stations that operators have deployed, wherever they are seeing a bandwidth crunch or wherever they see a lot of call drops or a lot of demand for the data, they selectively deploy 5G network as small cells where the 4G base stations will act like a macro cell. That is the idea behind these non-standalone. And also standardization is going at a slower pace. There that whoever wanted to take advantage of the 5G, they can go ahead and deploy 5G base stations by using the 4G as the core network. But again, you see, one can also deploy in standalone mode. Later, as part of the phase 2, as I was mentioning, it is going to cover use cases that are meant for IoT devices and meant for time critical and autonomous vehicle kind of thing. And one other point I should make here is last year in 2020, 3GPP has submitted both release 15 and release 16 specifications to ITU as one of the candidate technologies for IMT 2020. As I was mentioning in the previous class and also in the beginning of today's class, ITU only provides what should be the requirement for 5G network. It says that whoever is designing 5G networks should have, or whoever is developing technologies for 5G should meet this requirement in terms of the latency, data rate, number of users, battery life, and other things. If you recall, I was talking about 13 key parameters or capabilities that 5G network should support. Out of the 8 of them have been recognized as the main ones, which we have seen as part of the spider web diagrams. So like that, IT only talks about giving a bigger vision, but somebody has to take that vision and come up with architectures, protocols, and other things to realize that vision. So that is the kind of job that 3GPP is doing, or different standard development organizations who are part of the 3GPP are doing, where they have taken whatever the work that have been done as part of 15 and 16 to ITUR and ask ITU to check whether this technology is meeting their requirements or not. So ITU does its own independent thorough revision in terms of conducting experiments with these technologies and whatnot. And if they really meet all those different capabilities that I was talking about, the peak data rate of 20 Gbps, latency less than 1 millisecond, supporting speeds up to 500 kilometers per hour, and all those things that I talked about, they verify all that on some controlled experiments. If they really meeting those uh, conduct those trials and other things, then that technology is kind of accepted as a 5G technology. So like that, both release 15 and 16 have been submitted to ITU as candidate technologies, and they kind of pass the ITU requirements for 5G. And another interesting development that happened in the last 3 4 years is the THDSI, which is the Telecommunication Standards Development Society of India, which was formed very recently. So they also proposed another candidate technology for 5G to ITUR. It is having acronym 5GI, maybe you can assume I here stands for India, where the Indian government and Indian academy and Indian industry, they put their resources to kind of get this particular thing submitted to ITUR. And in addition to release 15, release 16 of 3GPP, even the THDSI version of 5GI also has been accepted by ITUR as one of the candidate 5G technologies. So this happened in 2020. And you may be wondering why THDSI has to do, why not 3GPP has done, why can't 3GPP take 5GI also and put it as part of uh, one of the candidate technologies for 5G. So as you see clearly, 3GPP composed of several different standard development organizations. They belongs to various regions. Whereas TSDSI is the one that is representing India. And what they actually did is they have taken this standalone version of NR that is there in release, I mean, in phase one. So they have taken this standalone version and added something called low mobility. So what they felt was is India, and not only India, many developing countries, for that matter, countries like Canada, Russia, which have lot of geography with sparse population, they felt that we need to have cells with larger coverage. Originally, when 3GP was looking at 5G, they felt that 5G is mainly meant for providing high data rates in urban settings. But Indian government and Indian academy and other people felt that 5G should not create any digital divide. 5G should also take some of the use cases that are specific for rural regions, because India also we have so many villages without even 2G coverage today. So that way, if you put new technology where the cell radius itself is less than 2 kilometers, then tomorrow no telecom operator can try to deploy a massive number of base stations because the coverage of each cell is only 2 kilometers. So initially our THDSA asked uh, ITU to have inter-site distance of 12 kilometers, but there was a lot of resistance. Finally, it was agreed that yes, we can have cells which are larger than 2 kilometers. Finally, it was agreed to have cell site in, I think it is called inter-site distance. Finally, it was all agreed that 5G will support inter-site distance of 6 kilometers. That means I can have base stations deployed which are apart from separated from each other by 6 kilometers. But without this LMLC, it is only 2 kilometers is the distance that base stations can do. So what is the significance of that? All the channel models and all the physical layer and coding and other things, they are kind of optimized or fine-tuned for base stations who can have coverage maximum of 2 kilometers. But by pushing this particular thing, where THD has taken what 3GPP has done as part of standalone NR and added this as the additional requirement, and it is being called 5GI. So it is possible because THDSA is also one of the member organization of 3GPP. So any member organization can take 3GPP specifications and can make their own modifications. So that's what TSDSI has done. It has taken standalone NR of 3GPP and added these additional requirements to support low mobility large cells to take care of rural India use cases. And I think, fortunately, I2 has accepted. Again, I2 is nothing but a collection of various members that belongs to various regulatories out there. So many countries realize that yeah, it is important to have larger coverage so that we can have operators going forward and deploying 5G without requiring to put too many base stations. So that way, finally, you can see interestingly, 5G as such is not a single technology that you see. We have standalone NR, non-standalone NR, standalone NR with LMLC. These are the three different flavors of 5G one can think of. And after I2 has accepted this, what they will do is they will ask all these different member countries. I think they have around 200 plus countries. They will be asked to take these candidate technologies and ask them to approve and adapt them. So in the context of India, you can assume that any operator who is going to deploy 5G, Indian government may mandate them to deploy 5G version India. That way we can able to take care of the rural use cases as well. So here you see the timeline of the 5G in terms of what happened in release 14. So release 15 and release 16. So there are two things that you can observe here. Even in release 14, not only the work that is related to 5G has been taken up for standardization and enhancement, they are also looking at some of the enhancements that are specific to 4G as well. It is true even when it comes to even in the case of release 15. You can see even in each of these three releases, 14, 15, and 16, you see there are some features and some enhancement that are specific to 4G, and there are something that are specific to 5G. Here also you can see 4G specific enhancements and also 5G specific enhancements. That also you can see it here, 4G and 5G. And also you see the timeline between 3GPP and IMT 2020. So as I was mentioning, ITU gives this as the requirements. And 3GPP has submitted their release 15 and 16 to ITU, the initial submission, that means the draft specification of the 3GPP technologies. And after getting initial feedback from ITUR, the 3GPP kind of further fine-tune their specifications and finally supposed to submit these things. So this all happened in, I think, June 2020. And finally, yeah, it has taken up both release 15, 16 and 5GI as three different flavors of 5G, which different countries can go forward and deploy. And you can also see, interestingly, there are four other, in each release, you see there are four different numberings that you see 1, 2, 3, and A. Here 1, 2, 3 stands for stages of standardization in a given release, where stage 1 basically talks about the overall service description from end user point of view. Here you specify what we expect that particular release should provide from user point of view. And then in the stage 2, what is being done is to meet those requirements, an abstract architecture with various network components will be defined. Then finally in stage 3, when we have multiple network components with various features, how they should communicate with each other, what kind of protocol they should use, the complete specifications, very detailed specification will be there as part of the release 15. So when I ask you to look at any of the 3GPP release, basically I'm talking about the final release, which is complete in all aspects. Whoever is want to making any product, they can take the specification and start codifying it to make products. There is also another phase that is called abstract syntax notation.1. Basically, it is a kind of a specific language which can be used to exchange messages. Basically, it is like kind of way, like For example, in the case of digital certificate, I think use X.505 standard for the way to define various fields inside digital certificate. We use ASN.1 to define various data structures when you're defining 5G networks. Not only 5G, even 3G, 4G also, same ASN.1 standard has been used to define the various data structures that are used at various network entities. And also, when you're talking about two entities communicating with each other, we have to do serialization and deserialization of the message. Because many times when you're talking about a packet, let's say if it is IP packet, we say this is the header, which contains various fields, and this is the payload. So when you want to send it over the network, we'll be taking these different fields and you serialize it and send it over the network. And at the other end, you deserialize and again you recompose the IP packet and send it to, let's say, transport layer or IP layer, whatever it is. So all these are kind of should be standardized so that when two entities are communicating, they should expect what is the order in which various fields inside a given packet will come. So all that has been defined as part of the ASN.1. That way, finally, after stage 3, 3GP, what it does is for all the standard ones, they kind of provide ASN.1 data structures. Whoever wants to make 5G products or any cellular products, they can use these data structures as it is because one can easily convert these ASN.1 data structures into, let's say, C language or any other language that you want to use for developing your protocols and standards. So this is the timeline and the context of release 16 and 17. So as I was mentioning, because of COVID situation, release 17 is supposed to complete by this year. I mean, by 2021, it is getting pushed to the first quarter one of the 2022. This is about the release 17. Okay, if you look now, you can see stage 2 of the 16, stage 3. After that comes ASN.1 specification of that. Then you also you can see that there is some parallelization of the releases as well. Not that after one release complete, then you see the effort for the following release happening. Not like that. You can see different teams do these things in parallel so that we can speed up this standardization effort and so that we don't lose the time and technologies become obsoleting in this process. So this is the timeline finally for release 17 and 18. So yeah, you can see that currently by 2024, it is expected that the release 18, this is what I was mentioning about NR advanced, going to come. Okay. So let's look at some major drivers behind 5G. So when you're talking about 5G, again here, whenever I use the word 5G, I'm talking the 5G in a very broad sense, in the sense the underlying technologies, the architectures, protocol are more or less the same, whether it is a standalone, non-standalone, or 5GA, except for some specific features to support large cells and some specific things in terms of how the base stations will talk with the core network, whether they will talk with the 4G core network or the 5G core network. But our discussion is very generic because we are not going into that minute detail in terms of all these different flavors of the 5G as part of this course, because all of them are like kind of a very advanced details. Those who are interested, we can look at these things later. Let's look at what are the general uh, drivers. When I say drivers, what are different underlying technologies which are kind of coming as part of the 5G to offer the kind of speeds and data rates and latencies that we expect in 5G. So one of them being massive MIMO. So I was briefly telling about what was MIMO when we were discussing introduction to wireless communication, where we are talking about multiple antennas available at base station and also at the handset, using which the base station can talk with multiple users simultaneously. Not only that, for a given user also we can use multiple antennas, where either I can send same data through all antennas, where each antenna uses the same spectrum band, or we can send different data through different antennas. That way, either you can improve the coverage or you can improve the data rates. So as part of the massive MIMO, we are talking about 64 by 64 and even 128 by 128. What is the meaning of this? We are talking about base station, which is having an array of 64 transmit antennas, 64 receive antennas, and 128, 128 also similar thing, but it doesn't mean that your handset should require. In this case, when the base station is having 128 transmit antennas, it can decide to serve, let's say, 64 users, where it can use two of the receive antennas at each of the 64 users, or it can serve 128 users by using only one antenna at each of the receivers for receiving the data that is transmitted by the base station over these 128 different antennas. So yeah, this is mostly at the base station side, but nowadays we are also talking about on the handset side also 2 by 2 and 4 by 2, sorry, 4 by 4, where your handset also can transmit parallelly using two antennas or four antennas. By doing all that, you are kind of either improving the reliability of the communication or increasing the data rates. So by doing all that, we can able to increase the effective data rates and throughput that user can enjoy. The second one,
So,
yeah.
so if we are packing all of those transmitters together,
Hmm.
won't there be interference between them?
Yeah, you are right. So that is absolutely what people who work on massive MIMO communication will study and come up with solution to address these issues. You are right. It is extremely challenging because when we are talking about using 128 antennas in a very close place where all the antennas are using the same spectrum band, then there's going to be a lot of interference. But we are talking about here something called orthogonal frequency division multiplexing. And earlier, historically, in wireless communication, people used to think that this multipath effect. That means when A is sending data to B, you not only receive the data in straight line, you also receive the data which is not. And again, I should not use the word data. When you send signal, when I say signal, I'm talking about RF waves. You not only receive the signals in straight line, if there is a line of sight path available, you also receive signals that are bounced off because of various phenomena like reflection, diffraction, and other things. You will get multiple copies of the same signal. That is there even when you use one antenna as well. But as you start using multiple antennas, this thing is going to be increasing like anything. But with advanced signal processing techniques, with some codification at the sender side, you can able to figure it out which one is the interference, which one is positive signal for you, and accordingly you can able to uh, reconstruct the originally transmitted signals and give it to the higher layers. That's what people who study massive MIMO will work on.
Okay, sir. Yeah.
Yeah, we are not going to talk about that. This is what I was mentioning about that people who are working on wireless communication and physical layer, they deal with. Okay. But we'll talk about only from layer 2 and above, the data link layer, network layer, transport layer, and other thing. Okay. And other major driver for 5G, which I already implied earlier as well, is usage of these millimeter waves. We're talking about using the spectrum all the way from 30 to 300 gigahertz range. So far, except for some deep space networks and other thing, we were never, I think, including even this satellite, basically the dish TV kind of thing. We were never really using this kind of spectrum for cellular communication. Cellular communication, for majority of the part, they are concentrated in the less than 3 gigahertz. You start all the way from 500 megahertz to 3 gigahertz spectrum in the wireless medium. But this is the first technology where we are kind of looking at can we use these millimeter waves for wireless communication. But one problem with this millimeter wave is the coverage. The coverage is in the order of 50 to 100 meters. What is the meaning of that? Earlier I was talking about inter-site distance, where I was talking about as part of LMLC, I was mentioning it is eight, sorry, not eight, 6 kilometers. But when it comes to massive MIMO, sorry, not massive MIMO, the millimeter wave, the maximum radius of your cell is maximum of 100 meters. That's it. So when you say 50 to 100 meters, so what do you think about it? Earlier I was talking about low mobility large cell to take care of the rural India use case requirements. There we are talking about radius up to 6 kilometers. But now I'm talking about deploying base stations where the coverage of each base station is 50 to 100 meters. So what do you think about uh, use application of these kind of cells? Where do you think we need these kind of base stations?
We need this in very dense regions where like industries or malls or some place where lots of people are there gathered together.
Yeah, but can you think of any other technology which operates in the similar range, 50 to 100 meters?
Wi-Fi,
Exactly. So interestingly, the millimeter wave that you see here, in other words, the millimeter wave version of 5G is going to compete with Wi-Fi
right?
because millimeter wave is mostly meant for indoor. Of course, having said that, some of the uh, industries are also actively looking at how to use millimeter wave in outdoor as well. That is also possible because one advantage with outdoor is even when you have 100 meters this kind of range, we can able to really provide high data rate in outdoor setting like talking about like a factory setting or shipping yards, those kind of thing. But we can also think of even deploying Wi-Fi as well because Wi-Fi also can have better coverage when you go outdoor compared to indoor because only indoor we have these issues related to walls and other things which eat away your signal in terms of 5 dB or 10 dB. That way, when you go to outdoor, yes, Wi-Fi also could be a good alternative to 5G, where 5G is going to talk about using millimeter wave. Even Wi-Fi also has certain spectrum. There's something called Wi-Fi also operates at 60 gigahertz. That is called 802.11 ED. So it has been defined many years ago, but unfortunately, we have not seen any application of this kind of radios. That way, there is no clear application that has made this particular technology popular. Same thing could be the fate of even millimeter wave of 5G, unless somebody come up with innovative applications which demand these kind of data rates. This may not really see any mass adoption. And other one is ultra dense heterogeneous networks. I was talking about 5G more like a small cell and 4G being a macro cell. And operator can think of deploying many such base stations which are overlapping with each other, but they have to kind of talk with each other to avoid interference, especially for cell edge users. And this is also very interesting feature of 5G. So we are talking about something called multi-access connectivity. Here we are talking about the 3GPP technologies, non-3GPP technologies, including satellite, working together to provide ubiquitous coverage. I think today morning I have shared one article where we are talking about, I think, Amazon and also I think Starlink kind of thinking about coming to India to provide satellite-based internet connectivity. So it has many advantages, and having said that, it also has many challenges. So now there's a lot of push even in the 3GPP to bring terrestrial networks jointly with aerial networks using these low Earth orbiting satellites kind of thing. Where when I say non-3GPP, it could be Wi-Fi or it could be satellite based thing as well. So there's a lot of thing because now we're talking about drone based communication or drone to drone connectivity and other kind of use cases. For that, when you have satellite, even though it has a longer propagation delay, thing is because from satellite to the ground, it is you always have line of sight and the path loss that you experience in this top to bottom will be kind of much less compared to when you transmit on terrestrial region, because on earth we have a lot of obstacles which kind of eat away the signal. But whereas when you come to this north south, that means between ground stations and the satellite, yes, there could be some issues when there are raining and cloudy and other thing, but otherwise it's more or less we have kind of liners of all the time available, and you can able to even cover these regions like hilly terrains where because of the landslides and other regions you may not even able to provide the fiber connectivity as the backhaul connection there. That is this multi-access connectivity to provide ubiquitous connectivity for the users, no matter whether you are on earth or underwater or when you are flying in the aircraft or in passenger drones. So the 5G is kind of take care of those kind of use cases. Of course, it may take another 5 to 10 years, but that's where the things are kind of talked about as of now. And there's another interesting thing I will talk about in the context of 5G core network is something called service-based architecture. So we hear they're talking about using something which the software industry has adopted for many years. There's something called service-based architecture, which basically talks about publish and subscribe. Where in the 5G core network, we have many entities like we have something called what you can say. We have this kind of there are many entities. Okay, one is called something called authentication function. Other one is called access control function. Other one is the policy and charging rule functions. These are all different components of the 5G core network which are supposed to work with each other. So as part of this service-based architecture, the way it has been defined is they brought in the best of the software engineering principles to the 5G core network so that these components can become stateless, flexible, and open. So the beauty of the stateless is we can able to run on any virtual machines or containers. The 5G core. Once it is stateless, and the migrations also become quite easy. So you don't have to copy the state of the network function when you're trying to migrate from one virtual machine to other virtual machines or one server to other server, or when you want to do any kind of load balancing or other kind of thing. So all those benefit you can enjoy in 5G core thanks to the service-based architecture. So I'll talk about what is SBA and how it has kind of embraced these software engineering features, including what you do in the case of HTTP. So basically we use again HTTP here. Of course, we use HTTPS for security. At the end of the day, it's more like kind of a sending HTTPS get command kind of thing when you wanted to request something or when you wanted to replace something. So everything is defined or coming very close to what a cloud computing community does, what software engineering community is doing, and what IETF is doing as part of HTTP 2.0 version kind of thing. So all those things have been brought into the 5G. That way you can see 5G is not something very different from what you do when you talk about internet, where we use IETF related standards. And when it comes to this uh, softwareization and cloudification, there are many technologies that 5G is adapting, which have been talked about in the case of internet for many years, for the last 5 to 10 years. One of them being network functions virtualizations, where here we are talking about rather than using dedicated hardware appliances, we wanted to use general purpose processor. That means we are using, let's say, Intel Xeon processor, which is a general purpose processor. We can use it to execute different kind of programs. Now, as part of the NFE, what we're talking about is we can take the 5G network functions and we can implement them as either network functions or also now people are talking about cloud native functions where they're talking about microservices where you divide each network function further down into small function calls kind of thing, where you can able to run all of them on general purpose processors. That means you can take AMD general purpose computers, or you can take Intel, or you can even take the ARM based processors rather than buying some specific appliance from one specific manufacturer. Where the beauty of that NFE is you take the software from one of the NFE vendor and you buy the hardware yourself by going to, let's say, Intel or AMD or ARM, and you can install this software on the hardware that you bought. The very similar to the way you install different applications on your computer. The operator can think of buying hardware from one vendor and buying software from other vendor, where since we are using general purpose processor, where the cost of the general purpose processor are supposed to be cheaper than buying these special purpose processor which have been kind of engineered only for one particular application kind of thing. That is the cost of purchasing hardware comes down drastically, and also there is no vendor lock-in. You can, if you don't like or if the hardware becoming obsolete, you can buy next generation of the processor from Intel family or AMD family kind of thing. That way we are kind of doing separation of the hardware and software. When you go to when we're talking about NFV, NFV is nothing specific to 5G, but 5G is the first technology where 3GPP is kind of embracing NFV context for cellular networks. And next one being network slicing, where you are talking about slicing both RAN, that means the radio access network, and also the core network. What is the benefit of doing this slicing? Again, we'll come back later, but at the high level, what slicing means is providing different logical networks for different end users. For example, when I was talking about EMBB, URLLC, and massive MTC, those are the three broad levels. But under each also, we can categorize the users and applications into different categories. So what network slicing does here is we are talking about creating one virtual network for each of these kind of end user segments. If the operator is interested in providing a 5G connectivity to, let's say, Indian railway network, they can create one virtual network on their physical infrastructure for Indian railway. Similarly, if they wanted to create, or if some other company, let's say, some we can think of, let's say, all the cab service, let's say Uber kind of cab service, where they have the pan India coverage. Where Uber want all the kits that they have deployed inside their Uber vehicles to be connected on one 5G network. Uber can tie up with one operator where the operator will create one virtual network for Uber so that the Uber drivers don't face the kind of connectivity issue that you see sometimes. Sometimes you might have seen the drivers struggling to get connectivity and getting the navigation information. That's because they also use the same network that you are also using when you're sitting in the passenger seat, because they don't have any specialized network, because they need better queues than what you supposed to be getting in that particular context when you are hiring a taxi. But 5G is supposed to take care of these kind of use cases where different end users and different markets can purchase different virtual networks in the form of network slices from the same operator, so that you can get guaranteed QoS and able to have your ability to guarantee the customer satisfaction and whatnot. SDN and orchestration. So you also might have heard about SDN, software defined networking. Basically, we are talking about programmability into the network, where we are kind of taking control plane and data plane separate, and where the control plane can modify the way your data plane behaves on the fly. That way, the programmability is kind of very important. That way, your network tomorrow can become entirely like a new network, because you have completely changed the way it behaves. And using orchestration, when you say orchestration, we are talking about doing both vertical scaling and horizontal scaling. When I am talking about scaling, this is in the context of the cloud, where the operator who have deployed kind of OpenStack or any kind of cloud for realizing their core network, they can use this kind of scaling technique to dynamically increase and decrease system resources that you have to provide for different NFVs. That way, when the network demand increases, then you provide more resources. When the demand is less, you can sell those CPU cycles to other applications and get some revenue out of that. That's what Amazon is doing as part of AWS and other things. That way, SDN and orchestration are kind of already built into the 5G networks. So where if you look at the 5G core, HD is completely based on SDN concept. The 5G core is divided into two parts. One is control plane and data plane, which are kind of separated with the standardized interfaces between them. And orchestration also has been standardized, and one can use this orchestration along with SDN, NFV, and network slicing to provide various kind of 5G services quite easily. Cloud Run, I think maybe I will talk about this further. So the idea behind Cloud Run is rather than having monolithic base stations, can we also split the base station into 2 to 3 parts and get each part of the base station from different vendor and make these components interoperate with each other and deploy these components at different locations depending on the network slice requirement that we have. That way the operator can think of reducing their operation and uh, capital expenditure. And mobile edge computing is another interesting concept or technology that 5G operators are very keen about, where rather than doing the computing in the core, where you may be having 50 to 200 millisecond or sometimes even 1 to 2 seconds as the end-to-end latency, if you can able to do the computation at the edge of the network. When you're talking about edge, here I'm talking about deploying some high-end computing server using virtualization technologies next to the base station, where we can do some kind of applications like providing video caching or providing these kind of multiplayer gaming kind of thing at the edge of the network. So this will have far-reaching consequences because if you look at any telecom operator today, they make money. Earlier, they used to make money by selling SMS packages, by selling voice packages. But nowadays, nobody is buying SMS package. Nowadays, you get SMS package bundled when you recharge your mobile phone. But that was not the case earlier. Earlier, they used to get even 20 to 30% of the revenue only from only through SMS. But now that revenue stream has dried out. Now they get only through voice and data. But historically, if you look at the revenue that operates getting from voice is also declining. More or less, it's more like you get 1 GB or 2 GB per day, and you pay around 200 to 400 rupees per month. That's where currently the subscription rates are for different operators in India. But now operators are also keenly looking at can we get non-human users so that they can also get more revenue from the same network that they've deployed. So that's what I'm going to talk about. But when you're talking about non-human users, for example, take the example of a telecom operator providing this kind of Uber connectivity service where they wanted to make sure that let's assume that Uber is also thinking of providing autonomous vehicle for cab service. Then you wanted to have this autonomous vehicle talking with each other in a in a reliable manner, and also they wanted to ensure that they don't collide with each other and whatnot. In this case, these vehicles will require very low latency and very high reliability. Otherwise, you may also lose human lives. For that, by deploying this computing at the edge of the network, we can significantly cut down the end-to-end latency, and we can able to provide quicker response for the autonomous vehicles which are flying on the road. That's where the mobile edge computing comes into picture. So all these concepts that I'm showing here, NFV, network slicing, SDN, Cloud RAN, mobile edge computing, each itself can be taught as a full subject. If not full subject, each of them may require 1 to 2 months for teaching for you to fully understand. But I'm assuming some of you are learning some of these or already learned these as part of some other courses. But our treatment is at a high level so that you should be able to still appreciate how these different technologies are kind of become key drivers in 5G services that are going to come up soon throughout the globe.
Sir, what is the significance of NFV? Can we see that like and normally in conventional networks we have network boxes. So is it that something software visualization is replacing those network boxes?
You are right, Harinder. What I'm saying is very simple. Let's assume that you have a Linux machine with you, right? Most of you nowadays, at least installed in a virtual machine or natively in your computer, you have a Linux running, right? And let's assume that an operator wanted to install a firewall in their core network. They want to make sure that their network is free of any malicious traffic. What typically you do? You go to Cisco or you go to Juniper or you go to Checkpoint, or there's also Palo Alto Networks. These are the kind of market leaders in terms of providing firewall appliances. When you go to all of them, they sell firewall as a box. It is like a 1U or 2U rack and that you deploy in your data center, which kind of takes your network traffic and scans it and emits all the traffic that is free of this kind of any malicious things. That's what the typical firewall does. But all this box, for example, in our campus, we have purchased this box a couple of years ago, which costed us around 1 crore. And tomorrow, when you wanted to increase the capacity by, let's say right now, assume that it is supporting 3 Gbps or 5 Gbps as the aggregate throughput. But sometimes these boxes can be easily upgraded to support 10 Gbps as the user throughput as well by taking additional licenses or also adding 10 gig or 20 gig cards, which these appliances can support. I'm talking about SFA cards. So this is how typically many operators and enterprises think about deploying their network, where whether it is a router or whether it is a firewall or whether it is any other kind of middle box, these are standalone appliances, which comes with the hardware and software bundled, where the manufacturer of the thing like Cisco's and the Checkpoint, they design what is the hardware and what is the software. It is like kind of black box for you. What I'm talking about as part of the NFE is, take an example of one of the open source intrusion detection system. There's something called SNOT, SNOT. It is
Yes.
like an open source tool. You can download SNOT,
Yes.
and because you have a Linux flavor of SNOT, yeah, you download the Linux version, you compile it and install in your Linux machine. It could be a laptop or it could be a desktop or it could be a workstation or it could be a Linux server that we have in our data center, where you have purchased a workstation or a server with let's say 32 cores or 64 cores or 128 cores with 60 GB RAM or 128 GB RAM. So that is the hardware that you have purchased. But compared to purchasing an appliance which comes with the hardware and software from one particular manufacturer, buying these kind of software separately from different vendors, sometimes this could be from open source community itself, and where the hardware is kind of general purpose processor. Here I'm talking about x86 family of the things. We are not talking about designing any specific system architecture or computer architecture that is highly engineered for these firewall related application. Of course, if at the end of the day, if somebody asks you which one will give you a higher performance, the purpose built hardware, which is also come bundled with the software, versus general purpose hardware on which you can install any of the different software, sometimes could be the open source. Which one do you think is giving can give you better performance out of these two?
So, sorry, can you repeat?
So I'm talking about two different cases.
Yes.
One is you are purchase. Okay, an example of that could be, I think maybe it may be a crude example. Like look at Apple versus Windows ecosystem.
Yes.
What is the main difference between these two ecosystems? In the case of Apple, you get hardware, software from same Apple. When you buy MacBook or when you buy iPad, both of them are shipped by Apple itself.
Yes. Yes.
But when it comes to Windows, what happens? You buy a Windows machine from Dell or HP or whatever it is. You can buy with OS or even you can buy these Windows machines even without operating system itself. Then you go to online, purchase Windows operating system and flash it on a CD or a pen drive, and you can connect your computer and start installing it. So there in the second case, what you are doing is you are kind of deciding what is the hardware and what is software yourself. In the first case, you are getting both of them bundled together. But if somebody look at which one is highly engineered and specialized, Which one you can say out of these two?
I think the one which is bundled
Yeah,
because
exactly.
software is actually meant for that hardware.
Yeah, exactly. That way, because same vendor or same manufacturer is kind of giving you this together, they can optimize because they know in and out of each of them, right? They can accordingly customize and optimize the thing. But it is a kind of a closed system. What Mac does is, and also sometimes it could be expensive, but at the same time, it is also highly reliable. That's why many people like Mac products. But the beauty of Windows ecosystem is there is no such kind of locking. If you don't like the way Apple does the thing, or one Dell does, you can buy things from, let's say, HP, or you can buy from Lenovo or whatnot, isn't it? That way you have the freedom in terms of choosing the hardware and also choosing the software. So same thing also happens in the case of NFA, where operators need not to go to one manufacturer who bundles both the software and hardware together. There, you just build a data center where you purchase, let's say, 100 servers, which are based on, let's say, x86 architecture. Now you go to the market and figure it out, which are all different softwares of the 5G core network and 5G RAM available in the market, which can run on this software, sorry, run on this hardware. So here you bought hardware yourself and you are now trying to figure it out what is software that is available that can run on this hardware. So that way you get more flexibility and you can also save the cost. But in this process, there is also a chance that you may not get optimal solution. But that's okay because in sometimes what happens is the technology is becoming so obsolete. Uh, as long as it is working for a couple of years and few years, people may be happy and you can start easily replacing. That's what is happening with mobile phones and smartphones. That way in India, you can see that many people buy 10,000 and 15,000 phones every alternative year rather than buying a very damn expensive phones because you cannot be happy with the same product for many years because technology is evolving so fast. So something of that I'm talking about in the context of NFE. Again, NFE is something not specific to the 5G. Even in the internet as well, you can see many of the network functions like firewall, routing, and the deep packet inspection, intrusion detection, and other things are increasingly being deployed on these general purpose processors. And I think maybe I have to tell one more point. And what do you think, uh, like companies like Amazon, Google, Microsoft are using in their data center? What kind of server do you think they are using? Do you think they are using any special data center grade servers, or they are using the same servers that many of us will buy when you wanted to conduct experiment for our research?
Maybe hardware is large, but again, we have studied something like content distributed networks. Maybe they are dividing the same content over the
No,
similar
no, no,
servers.
no, no. I'm not talking about the applications and other thing. I'm talking about the physical hardware that is purchased by these big cloud companies for providing you these virtual machines and other thing. I'm assuming all of you know about AWS, Azure,
Yeah, yeah,
and
cloud
Google Cloud,
services.
right? Yes, yes. So what really these guys do is they provide these virtual machines on these general purpose processors. They don't really uh, go for purchasing any special kind of hardware there. But the beauty of their solution is purchase many large scale these general purpose processors and with a little bit of software that you can use for network management and server management, you can take care of the faults by doing the migration of the thing, by doing the load balancing. You think that you are given a one virtual CPU and with a certain virtual RAM, but where it actually running, you don't know. Even while you are running this application on this virtual machine on cloud, this may be actually getting migrated from one physical server to other physical server or from one data center to other data center. All these are kind of done using software defined networking principles in the backend by changing your IP address on the fly and by migrating your virtual machine image from one machine to other machine. So, in other words, what I'm saying is the software defined networking and cloud computing all kind of making the operators to reduce their cost quite significantly. Rather than investing a lot of money on the hardware, buy damn cheap hardware. Nowadays, people also use the word something called white box switches and white box servers. What the meaning of white box is? It is like kind of plain thing. You can install anything that you wish, unlike some dedicated hardware which allows you to do only certain specific things. So now the industry is kind of too excited about using these white box technologies to massively bring down the cost of the hardware. Then using these different orchestration techniques, virtualization technique, and container methodologies and microservices, you can able to give an abstraction of having uh, large amount of the computing with a lot of storage, with doing so many underlying things in the background which end user need not to aware of it.
But yes, sir, when we see in the areas like deep neural networks or machine learning, as computation is increasing, there is more and more data, more and more parallel processing is required. They are coming up with very strong hardware as well. For example, NVIDIA has systems like DGX system or something. So can't we say that as networking, they are increasing speed, they are increasing devices, so they are also bringing a strong hardware, like the people who are working in deep neural networks, they are bringing more hardware for supporting parallel processing or something like this.
No, no, Rinder, what you said is correct. I think you are talking about and GPUs and other things that, yeah, yeah, you are right. So far I'm talking about the computing, generic computing, but you are talking about ML related computing. Yes, but but whatever I said about general computing can also be applied in the case of ML related computing. There we are talking about TPUs and other
Yes,
things
yes.
that there. But again, see, as you see, TPU is also another general purpose architecture that Google has come up, on which you can run any kind of machine learning computing task. It's not that you can use TPU only for one kind of ML activity, isn't it?
Yeah, basically it gave computation power.
Yes, yes. It is a kind of different kind of computing power that machine learning applications demand, versus the typical computing that use on x86 processors. That is, whether it is a CPUs or GPUs or FPGAs or ASICs, all of them are meant to provide some kind of computing power which your application wanted to do. But what I'm talking about is using a standard architecture which is the kind of produced in millions and millions of units every year. When you're making any server or designing a server using these uh, uh, system architectures which are produced en masse by Intel, AMD, the cost of building your server comes down quite drastically, right? Because the cost of the hardware is cheap, and now we can able to put any kind of software, and if you are not happy, you can replace the software tomorrow. You have a kind of highly flexible system rather
Yeah.
than the case that I was talking about. Like, for example, some of you might have purchased Wi-Fi access point at your home. Do you think tomorrow you can use this Wi-Fi access point? Right now, it is for Wi-Fi 4 as Wi-Fi 6? No, right? Because that Wi-Fi access point is kind of a closed door Wi-Fi access point that has certain hardware and it has certain software. You don't have any freedom to upgrade the hardware or to upgrade the software. It is a kind of a rigid system that is out there. But what I'm talking as part of this 5G and in general in the cloud is people are talking about using general purpose hardware on which you can able to run any kind of applications, so that there's no locking, there's no vendor locking, and also there's no application lock-in. So you can reuse the things as things go by. And when it comes to the reliability, I agree that these systems are not that reliable, but with these kind of techniques like load balancing, migrations, vertical scaling and horizontal scaling, you can able to kind of mask all these errors, and you can give the feel of as if Google is providing a cloud of millions of cores to a end user or an enterprise who deployed their service on that. But in the background, you do all this kind of software engineering and software defined networking techniques to provide that kind of illusion.
Okay, sir.
Okay, so any other doubts, I think whatever I'm showing in this slide, these are very, very broad in nature. And yeah, this kind of tells at very, very high level what is there in store when we are talking about 5G. Any other comments?
Sir, by mobile edge computing, does it mean that the operators would provide a mini cloud kind of a setup so that for the 5G applications, some amount of computing can be brought in towards the users?
Yes, yes, that's what I'm talking about. It could be either operators or it could be like some logical partners with operator, like you may be hearing about it. Google and I think Reliance Jio are partnering with each other. Or if I'm not wrong, I think Facebook and Reliance Jio, right? So in India, there's a news that I think Reliance is partnering with Airtel. Sorry. I shouldn't add Reliance. It is Google is partnering with Airtel and Facebook is partnering with Jio. So what is the significance of that? You can expect tomorrow Facebook data center is playing the role of mobile edge computing when it comes to geo base stations.
Okay, okay.
Either J itself can deploy a mini cloud next to their base station sites, or they can ask their partners like Facebook to deploy a mini cloud next to their base stations, so that all the Facebook related computing and all the geo services can be serviced locally rather than going faraway regions where the core network is deployed. That way you can see high response time for the users. And also you can think of new applications requires millisecond latency and other thing can be easily realized when you have this kind of MEC rather than requiring to go all the way to the cloud.
Yes. Okay, sir.
Yeah,
Sir, this radio access network, will you be explaining it later in the course, sir?
yeah, of course,
What
of course.
exactly?
Yes, you are right. The next class will be on the 5G architecture. So there we'll start discussing about what is RAN, what is core network, what are all the entities that are there in the RAN, how they communicate. Same thing we'll discuss about 5G core and how the 5G core already has embraced SDN and what is the service-based architecture. All of that will come as you
Oh,
go forward. Yes, yes.
okay, sir. Okay. Thank you.
So looks like we don't have time. Maybe I think I will stop at this slide. I think this is the last slide that we have. So here I'm showing you some of the things that are coming are kind of being embraced as part of the 5G. Here you can see what I'm showing here is most of the things are related to the open source, but there could be also some proprietary things as well. You can see I'm showing at the bottom Intel ARM based systems that can be used as general purpose processors, and you can run things on Linux, and you can also use using things from Xilinx where they have the DSPs and FPGAs and other things. Where what happens is some of the base physical layer functionalities in terms of the modulation, demodulation, channel coding, which are kind of highly computational intensive, which you cannot able to do in the time limit that is available. You can offload to the these kind of accelerators. So that way you can do this kind of mix and match using CPUs, GPUs, FPGAs, and ASICs for doing the computation. And you can see on the left-hand side, all the different standardization bodies and technologies. ITU, under that we see 3GPP. There it has come up with the LTE technology. Also, we are talking about using IETF standards, which are mainly meant for internet, because who is using 5G without internet? We are all using 5G. At least humans, we are using 5G for internet access. That way we see there's a lot of um, integration of the IETF standards and IEEE standards, 3GPP standards as you go towards 5G. So let me stop it here. And if there are any further questions, I can spend some time. Okay, next class, we'll talk about the spectrum that is made available for 5G. So 5G is going to come up with a lot of more spectrum than what we are using today for 2G, 3G, and 4G. A lot of spectrum. which was earlier earmarked for different kind of application like military applications, deep space applications. They felt that that is not really being used. By repurposing that for 5G, we can see a lot of more GDP growth for different countries. So that's what has been kind of many studies have advocated, and that these different regulatory bodies in India we have tried Telecom Regulatory Authority of India, and in United States we have FCC, Federal Communication Commission. So all these kind of things, these entities decide what spectrum should be used for what applications, so that the countries have more revenue and growth in their GDP and address the digital divide and other kind of issues. So we'll talk about what is coming up as 5G spectrum and how some of the spectrum that was earlier used for 4G is going to be reused in 5G. Then we'll talk about 5G architecture, what is RAN and what is core. So this, yeah, I think it will follow in the following classes. Okay, so I think we are already late, but any comments or generic comments? Again, today I have not taught anything highly technical. It's more like kind of overview of what is 5G and what is there in 5G that you should be excited about. No more comments, no more queries.
Yeah. No, sir, I think it's fine.
Okay.
So in the next class on Tuesday, we are going to start with RAM.
Yes. No, we'll talk with the 5G architecture. See, 5G architecture, when you say 5G architecture, it comprises of both the RAN and core network.
Okay.
So we'll talk about what is 5G architecture, then we'll talk about what is there in RAN, what is there in core network. So yeah, we'll talk about these two main branches of 5G system in the following classes, one after other.
Okay. Yeah. Okay.
Okay, good then. I'm stopping the recording. We'll catch up again on Tuesday.